Hello everyone, my name is Victoria Alt, and welcome to my presentation about the information worlds of software engineers. Who are they? Software engineers build and implement the software that we use in our everyday lives. They use programming languages that dictate the digital world for different purposes. For example, Python and R are languages used for data processing, while Java is used for internet and smartphone applications. Some languages work for back-end development, which is not directly accessible by the user, but affects how the software works. Front-end development is the exact opposite. Users access this part of the software directly. This could be construed as the user interface. Software engineers can work for firms like S&C Electric Company, Bank of America, and BuzzFeed, which don't deal directly in software development. As LIS professionals, we hire engineers or learn the trade ourselves to build ILS, OPAC, database, and analytics software. Software engineers can either be self-taught or have higher education degrees. During my research, I encountered articles about graduate programs, but I also interviewed 2 engineers that were completely self-taught. Some firms, like the Nerdery in Chicago's West Loop neighborhood, will administer a test during the application process to ensure they're hiring experienced engineers with good problem-solving skills. A degree is not always necessary. The way that software gets built is in an integrated development environment, or an IDE. This environment provides the conditions that engineers need to type and test their code. Frequently, screens are split between the IDE and the system being built in order to test programs in both interfaces. This workflow, coupled with other factors I'll mention later, affects the way software engineers seek information. The information behavior of software engineers affects every single one of us who uses digital tools to conduct everyday tasks. In this country, we mostly depend on software for accessing information. If software engineers are unable to access the information pertinent to building systems, then they take more time to complete a task. They could also write code that may potentially break other parts of the program down the line. Unlike information professionals, professional software engineers do not have authoritative sources to assist them with problem solving. Given the magnitude of the field, the amount of languages in use, and the iterative nature of the work, it's no wonder they don't. However, one might think that those conditions also make it highly necessary or important to have accessible databases. How do they navigate these vast amounts of information without them? While researching this group, I discovered that each engineering problem that requires information seeking is incredibly specific and not likely to present itself anywhere else. Thus, when seeking solutions, berry picking and nonlinear information seeking are the methods of choice and necessity. Peer-to-peer information seeking is the way that many engineers satisfy information needs when working in teams. This is due to the proximity of the source and the ease of applying the new information to the information need, because the context remains the same. Proximity to information also dictates the information behavior of independent or remote engineers. It is easier to consult forums like Stack Overflow instead of emailing and calling someone who cannot provide direct comparison to the problem at hand. Books, internal databases amassed throughout a firm's life, and documentation written by the programming language authority are all sources used to supplement this information. Each article I consulted was only done within single firms instead of having a diverse sampling. Many focused on information flow through different levels of management or project lengths. I also interviewed a few acquaintances that work in the field. They told me that there is little time for database use and that a basic Boolean search on Google is an accepted method of finding valid information. In addition to this difference, I learned that some software engineers are creating meta-heuristics, or high-level procedures designed to find sufficient information to solve optimization problems. These engineers are learning to formulate queries within their programming language to return pertinent results. I also read an article about the way software engineering is taught at a graduate level as opposed to the actual workflow that exists within the professional field. Academic institutions provide special access to computer science databases, but these resources aren't tailored to engineering and soon disappear as the student graduates. The students are being prepared for a workflow that doesn't exist outside of academia. Though the literature revealed new and useful information, the studies were not conducted across larger samples. We only know the information behavior of those specific firms, not the information behavior of the field as a whole. Also, the interviews I conducted made me question whether or not software engineers would use a database. The UI and search process would have to be similar to Google, but specialized enough to answer the queries quickly due to the immediate need for information. The firms would also have to be willing to pay for access, and it was not lost on me that trying to aggregate every software engineering problem and solution would be a bit like Library of Congress's efforts to catalog Twitter. I've found that peer-to-peer and online information seeking are the ways that many engineers choose to seek information. There is no one almighty source that they consult. Chapman's small worlds theory is very much at play here. Practices that would not be professionally acceptable to us as LIS professionals are perfectly normal worldviews to software engineers. Google and the sources it presents are valued, as long as software engineers allow for legacy information to be easily accessible for future modifications, then all is well. For example, a site like Stack Overflow, which can be likened to Reddit and Wikipedia's baby, is a valid source. A software engineer would piece together the solution using forum entries dealing with similar but ultimately different problems. The solution would be put into the program as code and tested. If the solution works, then a good engineer would add comments to the code. Comments exist to inform other engineers working on the project. If an engineer does not comment their code well or at all, then the piecemeal solutions that were implemented may not make sense to other engineers and prevent future work on the project. Disruptive influencers would include those who challenge the reliable authority on project management teams. For instance, an interview subject said that they were trying to find a way to tell the authority figure, their project manager, that the task assigned to them caused redundancy within the project, and they were working on that and the integration that would save time to make the code more efficient, all without looking like a disruptive influence. Many engineers must find ways to navigate information seeking that require remote correspondence, so as not to seem unqualified or bad at taking direction. This fear of seeming unqualified can dictate how long a task takes, and make the engineer seem unreliable to their project team. The social norms of this small world definitely affect project management. The biggest influencers on their information behavior are due to the time constraints and need for efficiency that the firms place on engineers. They use berry-picking and nonlinear information seeking to accomplish the tasks at hand. This is especially true due to their work being full of imposed queries, the results of which their coworkers and patrons rely on. So, the biggest influencers that they have to deal with are the availability and proximity of information, so this could be different based on whether or not they are a remote engineer or working within a team. The time management and the project scale, because projects can last anywhere from 6 months to 10 years. And the social hierarchy within the organization also affects their information-seeking behavior. If business carries on as usual, there is a chance that software we rely on will be edited to the point of nonsense. So many custom solutions will have been implemented that the code could be redundant or altogether broken. An intersectional study should be conducted to better ascertain the information behavior and needs of software engineers. Without it, we may not be able to optimize the field and keep information use coherent. This would best be done with a naturalistic research study that uses interview as its method. By determining the feasibility of a database in these interviews, then we may be able to proceed with database creation for other fields that use iterative problem solving. Here are my references, and thank you so very much for listening to my presentation.